this will be an introduction to 8.3, which we're going to do tomorrow. So in 8.3, what we're going to do as an introduction, we're going to say, well, you decide that you're going to make a new password to get into your computer, and you're going to use your name and just scramble the letters in your name. So Ben starts. How many permutations are there for Ben's name? How hard is it going to be to break into his computer? Well, there's 3 letters. You could do 3 spaces, but can you see that it would basically be 3 factorial, right? And it's like 6 choices, and it's not going to take very long to figure that out. And Beth is like, oh, I've got so many more, but not that many more. Well, we'll get to you in a second. But right now, these ones are straightforward. Okay? Beth has a little bit more than Ben. Ramsey has more. Ramsey is more than Beth. But we have some people in this class. We have some people that are a problem. Okay? First problem that we have, who should we pick? Who thinks they're a problem?
I can't see it.
Shemi might be a problem if we use his whole name, yes.
Might.
Okay. Most likely would be a problem. Yes, you are a problem. Yeah, definitely. Carmela's going to be a problem. Yeah, Jillian, oh, problem. Who else is a problem, and why are they problems? Evelyn's going to be a problem. Even if we, let's start with Eve, right? It's not a very long name, but it is definitely a problem. Why is Eve's name a problem? The 2 E's, okay? She's like, oh, I'm going to switch up my password. Okay? Now, that would be different if we considered uppercase and lowercase, right? So that could be different, and if you do consider uppercase and lowercase, then Eve would still be 3 factorial. But if you say, hey, when I'm reading this, this is the same, then it's not going to be 3 factorial. Because, well, let's say she starts with a V. She could have made her password V or V. Okay?
Or
Eve or Eve. However you say it. So normally for Eve, it would be 3 factorial, right? But now, every combination gets repeated. So this EVE would have been counted like this EVE, but they're the same. So in order to, we'll have to cut, if these are the same and these are the same, and if we listed all 6 of them, I guess there's only one more, we may as well list it. The last one would be Eve or Eve. And those would be the same. We'd have to divide by 2 and find out that there's only 3 passwords. And so you have a pretty good chance of breaking into her computer. So now if we look at other problems, Carmela, oh my goodness, the problems. So Carmela's is even more obviously a problem because the A's are both small a's. So now we would have to say, well, I could, I guess, write it like this. But then, see, if those would be considered different, but otherwise they wouldn't be. And so 1, 2, 3, 4, 5, 6, 7 factorial is what she started with. But we have a repetition or of 2 identical letters. So we've got to divide by 2. Anybody think they're more of a problem than Eve and Carmela? Jillian? Oh, Jillian. What is wrong with Jillian? I know that question has been asked so many times. 2 L's and 2 i's. So if we considered that, how many different ways could I rewrite that would be identical? Right? So normally 1, 2, 3, 4, 5, 6, 7 letters. But how many times can I write Jillian by just mixing up the I's and the L's so it still says Jillian, but it's different? I could go J and then what next? Capital I, and then small l, big L, little I, A, N. Okay? Is that it? No? What else could I do? J, obviously. Okay, same capital L. Oh, and just switch the L's. Okay? Have we counted them all? No. J, small I. No, we've done that one. Little l, capital L, big I. So because she has the L's that repeat, we're going to have to divide by 2. And because she has the I's that repeat, we're going to have to divide by 2 again, because there are 4 of them. There we go. There are 4 of them that are identical. And at 2 times 2 happens to be 4. We'll divide by 2 once for the L's and divide by 2 again for the I's. Does anybody have 3 letters that repeat? How? Middle name. Oh, okay. What's your middle name? Alexandra? A-L-E. Oh my goodness, 2 S's and 3 A's. Now normally if they were all different it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things to arrange, which would be 10 factorial. We already know what happens when there's 2 of the same thing. So for the 2 S's we're going to have to divide by 2. What do you think you're going to have to do with the 3 A's? Okay? And we're not going to divide by 3. Now, I'm not going to write Alessandra out every single time, but I'm just going to, the first one here is like this. What would another arrangement be? I could start with a capital A, and then this one would be the alpha, and then the A, which is going to be, start with A, big A, fish. A fish, big A. Fish, small a, big A. Fish, big A, small a. Now, I could write 6 here, because all 6 are the same. Hello?
Isabel with Ethan at Robson, please come to the office.
Okay.
Thank you so much.
But since there was 3 letters repeated, what would be a nicer way of writing, instead of writing 6? 3 factorial. In fact, our 2's could have been 2 factorial. Because with 3 objects, you can arrange them in 3 factorial ways. And those will all be identical. That's your first name. We'll just do your first name. Okay. Oh yeah, I wasn't done. There we go.
You can spell my name. I feel so.
Of course I can spell it. I can. So normally this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Abnormally this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I lost count again. 2, 4, 6, 8, 10, 12, 13. Lucky you. And then the only repeating, 2 L's, so we'll have to divide by 2 factorial for the L's, 2 E's, 2 factorials, 2 O's, 2 factorial for the O's, right? And chances are you wouldn't be able to break into his computer. There are a lot of combinations there, even if you said, I just rearranged my name to put in there. So our next section deals with this. How do you arrange things when you have identical objects? And in our names, sometimes we have identical objects.